We are starting now question number 7 for this mechanics of kinematic. The question is, 6. A particle travels in a straight line from A to B in 20 seconds. Its acceleration 3 seconds after leaving A is A meters per second square, where A is equal to 3 over 160 t square minus 1 over 800 t cube. It is given that the particles comes to rest at B. Part 1. Show that the initial speed of the particle is 0. Part 2. Find the maximum speed of the particle. Third. Find the distance AB. Now, we know that acceleration is given to 3 over 160 t square minus 1 over 800 t cube, where it's going to stop at B. And we know that from this acceleration, if it is being integrated with formula number 9, then it is going to give us velocity plus constant of integration there. So first we are going to integrate this part for the velocity. So integration of expression into dt is equal to 3 over 160 t square minus 1 over 800 t cube into the derivative dt. So this is going to give us velocity according to this formula number 9. Then it is equal to, after integration, 3 over 160 t over 3 minus 1 over 800 into t power 4 over 4 plus constant of integration, because we don't know the limits of this integration there. But they stated in the problem that it takes 20 seconds to reach the speed of B, where speed of at B is equal to 0. So we put this condition into this velocity there. So velocity is basically at B point, velocity is equal to 0. That is 3 and 3 cancel. 1 over 160 t cube minus 1 over 3200 t4 plus acceleration a there. So that thing is equal to 1 over 60 t is 20 cube there minus 1 over 3200 into t is 20 power 4 plus value of a there, which is equal to 0. Then a value will be equal to 1 over 3200 into power 4, that is 16,000 minus 1 over 160 into 800. A after calculation is equal to 0. So V is equal to 1 over 160 t cube minus 1 over 3200 t power 4. For the initial speed, that means what? You put t is equal to 0 in this part. So it is equal to 1 over 160 into 0 cube minus 1 over 3200 into 0 power 4, and that thing is equal to 0 there. So this means the initial speed of this particle is equal to 0 and the start of this point A there. Then in the second part, they asked that find the maximum velocity of this particle. We know for the maximum velocity, you put acceleration equal to 0. So when acceleration is equal to 0, so this will become 3 over 160 t cube square minus 1 over 800 into t cube, and that thing is equal to 0. Or 3 over 160 t square is equal to 100 1 over 800 into t cube. This t here, so that is equal to 3 into 800 over 160 is equal to t here. So t value is equal to 15. So maximum velocity at t is equal to 15 will be equal to 1 over 160. T is there 15 whole cube minus 1 over 3200 into 15 power 4. And that value is being calculated equal to, now for the third part, the distance AB, that is equal to 0 to 20 v, because that is going to give us the displacement here. So x is equal to v is there 160 t cube minus 1 over 3200 t4. So this will become 1 over 160 t4 over 4 minus 1 over 3200 into t5 over 5, and the limits are 0 to 20. So this will give you 1 over 640 into t4 minus 1 over into t5, and the limits are 0 to. This is going to give us equal to 250 minus 200 after putting the limits, and that thing is equal to 50 meter. So the distance of AB is equal to 50 meter for that calculation there. So in this first we are going to differentiate and then we are going to integrate. But remember one thing in this question, that they are asking the maximum speed. So whenever they are asking the maximum speed, then for that part acceleration should be equal to 0, and we can get the time of that